Yeah, 8.1.3, number B. Now they say for which values of x is f concave down. So let's see. Now, when they tell us about concave down and concave up and all of that business, let me actually just scroll here. Yeah, when they tell us about concave up and concave down, and I need you to take note of this. Whenever they are talking about concavity, whenever you find a question regarding concavity, you need to use your point of inflection to answer it. Ne? So meaning you must figure out your point of inflection if it is unknown. So okay, and as I said that to find the point of inflection, you're just going to have to take your second derivative and equate it to zero, right? Or an easier way to find your point of inflection now is that now, okay, we have our turning points, right? It's 2, -9, then minus 1 over 3, and what's that? 100 over 27. So sharp. Once you have now your turning points, an easier way is that you can add the x coordinates of your turning points, né? And then divide them by 2. So I'm going to use both of them and we'll see. So I'm going to say now, what's this? My x coordinate of my turning point and x coordinate of my other turning point and divide them by 2. That's going to give me the x value of my point of inflection. And I only need that x value. So I'm going to say minus 1 over 3 plus 2 all over 2. And how much is that? How much is that? Uh,
5/6.
what are we getting? Please repeat that.
5/6.
5 over 6. Yeah? So also now, thank you. So I'm going to know my first derivative is 6x squared minus 10x minus 4. So my second derivative, that means I'm going to derive this guy, the first derivative. So it will be 12x minus 10, then the 4 will fall away. Someone is talking, please keep it down. So that's my second derivative, and I'm going to equate it to 0. So I'm going to have 12x minus 10 and equate it to 0. So it's going to be 12x is equals to 10. And then I divide both sides by 12. Yeah. Then x is going to be 10 over 12. Then I can simplify it by dividing both sides, both of the values by 2. Then I will have 5 over 6. So already you can see that either way we are getting the same answer there. But whatever works for you, whatever works for you, whatever works for you. But usually this method here that I showed you of adding your turning points and dividing them by 2, you're usually going to use them when you don't have your formula, because sometimes they can just give you your turning points and say, what is the point of inflection without having a formula. Then you know you just have to add your turning points and divide them by 2. So in that scenario, it's going to be handy for you. And besides, either way, it's easier because it's quicker, right? So whatever works for you, you're still going to get those marks. So, but then that was just the first part, né? That was just the first part. So finding the point of inflection is the first part. So okay, you found your point of inflection and you are happy now. You can move on to the next part. So the next part, what do you do? Okay, so we know that here I have a value of 5 over 6. Yeah? So it's just determining where is my concave down. So once you are here, you must look. We are going upwards, then we turn, then from here we are going all the way down until negative infinity. So from now, my point of inflection, yeah, going to the left now, because this is where I'm going. That means I'm having my concave down. That's where I'm having my concave down, right? Did we catch that, ne? So it's kind of a trick, you know. It's kind of a trick of just figuring out how to look at your point of inflection, how to get it, whether your graph is concave up or concave down. And even if the graph is looking something like this, can still do the same thing. Can still do the same thing, right? So sharp, because you're going to say, okay, here's my point of inflection. From here, going all the way, I'm going down. So now your point of inflection is when you're going to the right. No, your concave down, I mean, is when you're going to the right. So sharp, my concave down is when I'm going there. But then I must write it in terms of x. Ne? So how am I going to write it in terms of x? So let's get this. 5 over 6 is my x value, right? And I only need that. I don't need to find the y value for this question. So going to the left, do we agree that all the values going to the left, because as I'm going to the left on my x-axis, I will end up at negative infinity. So the more I go to the left, all of the x values, they become less than 5 over 6, right? So that's just how we are going to write them. So my answer will just be x is less than 5 over 6. Do we catch that? Is that good?
Yeah.
Okay. No, thank you. So yeah, let's not waste any more time and just continue. So yeah, you need to kind of familiarize yourself with these questions. So now 8.2, they say now if g of x is equals to px cubed plus qx squared plus rx, yeah, is a cubic graph, is a cubic function that further satisfies the following conditions. So they say p is negative. So if p is negative, okay, and then g prime m, which is equals to g of m is equals to 0, where m is positive. Okay, draw a sketch graph of g, clearly indicating one of the turning points of g in terms of m and all intercepts. So okay, let's put this into perspective. So we are at 8.2 now, guys. So we have g of x being px cubed plus qx squared plus rx. So already we don't have a value for d. So now when they say p is negative, that means they're saying this guy is negative. And in standard, situations, uh, this value now, the p or the coefficient of x cubed, in all situations, it tells you the shape of your graph. So in this case, if p is negative, that means my graph will look like this, right? That's basically what they say. Okay, so we've taken that down. And then when they say g prime m, so this is my first derivative, is equals to g of m, which is equals to 0. So let's start with g of m. So G of M will be me taking a point. Yeah? So M can represent any number, by the way. So if M is positive, that means it's here. Yeah? From my origin anywhere to the right. That's where M is, because it's going to be an X value, an X coordinate, right? Sharp. So it's anywhere on the right. And then when they say G of M, so this will be us taking M and substituting it into G. So it will be on the X coordinates. And then when it equals to 0, the what's that basically? So just look at this. G of M is equals to 0. Whenever I'm equating my graph to 0, that's when I'm looking for my x-intercept, right? So meaning at M, G of M and 0, that's where I'm finding my x-intercept. And since they're saying M is positive, it's going to be somewhere here, right on the right-hand side. And then the G prime M is equals to 0. Also, what did we say about that? So here we have x-intercept. And then a G prime M is also equals to 0. What does that tell us? Turning point. So in this case, my turning point and my x-intercept are at one position or at one point, right? Is that kind of making sense now? So yeah, now I've analyzed everything. I can start sketching. So let me sketch here and see how it's going to look. So let me change the color. So okay, let me use a ruler or something to make it proper. Here I am. Here I am. Boom. So what did we say? Okay, we know the shape of our function, and then my y-intercept, yeah, since there's no value for d here, since there's no value for d, that means my y-intercept will be at my origin, right? Because usually d, ax cubed plus bx squared plus cx plus d tells me my y-intercept. So if it's not that, that means my graph is going through the origin. So I'm going to go something like boom. Through my thing. And then since now I know that my x-intercept, so let's say my x-intercept is here. And we are assuming because we don't have the exact value. My x-intercept, so this is my y-intercept. But I know that my x-intercept is the same as my turning point. It will be here. So I'm gonna have my first turning point. Okay, no, let me take it a bit back. So here I am, boom. And let's see. So my graph will look something like this. So when I get here, I'm gonna turn again, going all the way down. So this is my y-intercept. This is my turning point. Then yeah, kind of something like this, né? Are we seeing it?
Yeah.
Okay. Yeah. So yeah, that took us long. That took us long. Let us see. What else can we look at for the remaining? Okay, I think let's look at this. Okay, before we jump into it, any questions, guys?
Tsebo,
Yes?
ne ke nyaka go botsisa maabane o itse a re ko o gopotse ka question e lano ko o tshwaretseng yona.
Okay, let me see, let me see, let me see. This one. Can you all see it? Mhm. Can you guys see my screen?
Yeah.
Okay. So it's question 8, né? So it's not. So this is first derivative. Okay, easy. So maybe your f prime x is just going to be what? 6x, né? Then you're just going to use your first principles. There we are, okay. And then this one, is it this one? 8.2.
Yeah, nka no e mara ne ke nyaka le 8.3.
Okay, let's look at, 8.2. Let's look at 8.2. Because it's actually interesting. It's a nice 5-mark question. So let's look at 8.2. So with a question like this, you want to be very careful. You don't want to be in a hurry. You don't want to, everything must go according to a certain order. So determine the derivative of f of x is equals to, so we have a bracket, 2 root x minus 1 over x whole squared. So before we can even derive here, remember we must have terms that are in this form, ax to the power of b. So that's our first goal, basically. So we are still gonna keep the f of x, and say now, since we have a square, we are going to just square out everything basically. So maybe, and it's kind of something like 2 root x minus 1 over x, then we can do 2 brackets. Yeah. Then continuing, I'm just going to use the shortcut though. I'm just going to square the first one. So when I square the first one, I'm just going to have 4x. Is that right, no? Because 2 squared, that's 4, and then square root of x or squared, the square root will cancel. The root will cancel with the square, then we have that, okay? Then with this one, I'm just the middle part, I'm just going to multiply out the 2 of them, then I'm going to multiply them by 2. So I'm going to have 2 multiplied by, so it's negative, yeah. Okay, let me even change the color. Let's see. So it's going to be minus 2, then multiplied into 2 root x, which is multiplied by 1 over x, right? So basically we multiply these 2 terms, then we multiply by 2 for the middle one. Then for the last one, we just square it. So it's minus 1 over x. So I'm just gonna square the numerator. I still get 1, I square the denominator, I get x squared.
Oh.
Or what? Are you guys saying something? So far, so good, though, ne? So, yeah, continuing. I'm just gonna keep this for x. And then let me deal with this one here. So I'm going to have now, I can just, when I multiply these two terms together, it's basically going to give me, since it's fractions now, so I'm going to have, let me keep the 2 here. Then I'm starting with the bracket, so it will be 2 root x over x. Yeah? Then plus 1 over x squared. Are we following? Then I'm going slow so you guys can see. Then when I multiply again, it will be minus 2 times 2 is going to be 4 root x over x plus 1 over x squared. Then I'm going again. We must take it here, right? So the 4x is okay. So let's see now. My first part will be to do what now? I can do either one of the following, but I'm going to show you this one because I think it's easier. So I'm going to start by saying 4, then I'm going to change this root of x into a rational exponent, and I'm going to say x to the power of half, and then it's divided by x, right? Then it's plus. So with the 1 over x squared, I'm just going to take x back here, and then it's going to be a negative, right? So it will be now negative x squared. Yeah? So basically that means I can remove this positive, then I'm gonna have a minus x squared, right? Then I'm gonna have f of x equals to 4x. So dealing with this guy now, it's minus. So I'm gonna keep the 4. And what's going on here? Basically, I have 1. So I have, what's this? I'm dividing exponents. So they have the same base. So what am I going to do? I'm going to keep the base, and then I'm going to subtract them. So I'm going to have 1. I'm going to have a half minus 1. That's going to be minus half. Are we seeing that? No? Write it down properly. Yeah. So f of x is equals to 4x minus. So I keep the 4. Then, yeah, same base, dividing exponents with the same base, I keep the base, I subtract the exponent, so it's going to be half minus 1, that's going to be minus half, then minus x squared. So now I can derive. So I'm just going to derive here, let me change color. I'm going to have f prime x is equals to, so when I derive 4x, what does it give me? It gives me 4, right? Then it will be, here I will have negative 4 multiplied by negative a half. That's going to be positive 2, right? Then I'm going to keep the x. Then it's going to be minus half minus 1, which is going to be minus 3 over 2. And then the last one, it will be minus 2x, because 2 minus 1, that's just going to be 1. So here's my f prime x for this one. Are we good with this?
Yeah, mara ke na le question one.
Okay.
Wa bona mo line ya before mo mo borete
Okay.
I get a f of x is equals to 4x minus 2, then what's in bracket? Mo kamera bracket to na le denominator x. Ke nyaka go botsa gore e tla kae?
Okay, so yeah, look here at the blue part. Ne?
Yeah.
Do you see here?
Yeah.
Yeah, so okay, let me highlight again with the yellow color. Look at the yellow color again. Where I'm doing with the yellow. It's in the bracket. So
Yeah.
look here at the top left. I'm gonna do it here. So if I say 2 root x, ne, this is the same as 2 root x over 1. Then multiplied by 1 over x. So how do I multiply my fractions? It's numerator times numerator. So I'm going to have 2 root x over denominator times denominator, which is x.
Oh.
And that's what I have here.
Yeah.
So yeah, then is everything good, ne? But with a question like this, it's not too difficult. You just have to take your time. You just have to take your time and kind of think through everything properly and nicely. Yeah? So let's just go to the one that you've wanted. 8.3, they say given f of x is equal to 3x cubed minus 3x squared plus 6x minus 2, then they say for which values determine the interval for which f is concave up. So this is what you wanted, right? So okay, we have our graph now. Now we have our function. We won't even try to sketch a graph, né? But we can kind of make a visual representation. So this value of 3 is positive. So that means that's A, right? So that means A is positive. So my graph is going to look something like this if I were to sketch. And that gives me a lot of context because I know that if my point of inflection is here in the middle, then my concave up will be going up there. So from my point of inflection going to the right, that's my concave. So as I said, when they are asking you for concave up or concave down, you must get your point of inflection. How do we get your point of inflection? That's your second derivative equated to 0. So we will say f prime x. Okay, let me even start with f of x, né? So you can see where we derived from in the beginning. So it's 3x cubed minus 3x squared plus 6x minus 2. Then the first derivative. What is that? 3 times 3, that's 9x squared. Then a minus 6x. Then a plus 6. Yeah? Then we're going to have our second derivative, which will be 18 x minus 6. So yeah, here's my second derivative, 18x minus 6. 18x minus 6 is equal to 0. So from here, I'm just going to solve for, what's this, for x, né? So whatever you want to do, maybe you can say, I see a common factor here of 6, so I'll take out that common factor, and it will be now 3x minus 1 equals to 0. Then the 6 will fall away. Then a 3x minus 1, I know it's going to give me 1 over 3, right? So it will be 3x equals to 1, and then an x. Divide both sides by 3. That's 1 over 3. So here's my point of inflection. So going back to the drawing again, let me show it properly for you guys. So now you're going to have something like, that's how our graph will look because our A is positive. Then the point of inflection is here in the middle. So the point of inflection is in a way where is in such a way whereby it's exactly in the middle of your two turning points. So here I have my 1/3. So if here's my 1/3, I know that to get a concave up, what's going on? It's here basically going to the right because I'm just going down a bit, then up all the way, right? So I'm going to the right. So also, in terms of my x-axis or my x values, when I go to the right, my values, I'm going to end up at positive infinity. But then my values are becoming, or they are all greater than 1/3. Right? Are we agreeing with that? They are greater than 1/3. So that means now my answer will just be x will be greater than 1/3.
No, thank you.
Yeah. So yeah, are you okay with the question, Donna?
Yeah.
Okay, good. Let me see. Let me remove everything and go back here. Okay, I'm just going to